This will start 7A section. This section talks about quantities. So we're looking at how much of a chemical you get or how many atoms you get, so that we can do labs, do experiments with certain amounts of chemicals. So we're dealing with the quantities of chemicals. Before we deal with chemicals, let's deal with something we know about, and I like to use the apple example. So I have 12 apples. And it could be 12 anything, but I'm going to use apples. So with 12 apples, that is my count. That's how many I have. So if somebody asked me to go to the store and get apples and said I need 12 apples, I would go to the store and count out 12. So I'd be getting my apples by count because I'd be counting out the apples. And I know that 12 apples is equal to 1 dozen apples. And abbreviation DZ. So we use the term dozen to mean 12 things, and it's just a shorthand way of simplifying a bigger amount into a smaller amount. It doesn't simplify it much. I don't think it's too much easier to say a dozen apples versus 12 apples, but it is a way to simplify. If we were ordering a lot of things, we might say 12 dozen instead of 144, but not too much of a difference. So the other way somebody could maybe go to the store and order apples would be by mass. And they could say, well, for my recipe, I need 2 kilograms of apples. So maybe you're making a pie or something like that, and it doesn't really matter how many apples you get. It really matters how much mass of apples you get, because there's big apples and small apples, and 3 big apples might make a pie, but it might take 6 small apples. So it would be more consistent to just say get 2 kilograms worth of apples. So I would go to the store, I would grab some apples, put them in the scale until I got 2 kilograms of apples. And let's just say that this size of apples, getting 2 kilograms would get me a dozen apples. So that's how I could get my order of apples, by weighing them on the scale. In a lot of ways, that can be faster. So if somebody wanted a lot of apples, like 300 apples, it's going to be a pain for me to go to the store and count out 300 apples. If somebody just says I need 10 kilograms worth of apples, that's going to be pretty fast. I can just start dumping them on the scale and get there pretty quickly. So mass is a lot more convenient, especially once you start measuring a lot of things. It's easier to just start dumping them on the scale until I get pretty close to what I want. The last way I could do it is by volume. So somebody could say, I want 0.2 bushels of apples. Bushels of apples is a way to tell you how many apples to get by volume. So apples used to be picked by bushels, like bushel baskets. Maybe you have one of those around your house. Or you can buy boxes of apples that tell you how many bushels worth it is. And in our example, let's just say this equals 1 dozen as well, apples. This would obviously depend on the size of the apples. So 0.2 bushels of apples equals 1 dozen apples. So with this, I am able to go to the store and get apples. I can either get them by count, I can get them by mass, or I can get them by the volume. Each one has different advantages and disadvantages. And in chemistry, we'd like to use the same idea as how do I get chemicals? Can I get chemicals by count, by mass, or by volume? So by count is going to be obviously really, really hard, because if I said I need 100 atoms of carbon, there's no way that we're counting that out or getting that with tweezers or something like that. So count is really difficult to get chemicals in. Mass, on the other hand, that's pretty easy. If I need a gram of gold, I can just go weigh that on a scale. It's a lot of gold atoms, but weighing out a gram, that's pretty easy. by volume, also pretty easy as well. Works well for gases if I need a volume of a gas. But for chemicals, we want to have some sort of dozen term that we can use, because it is easier to shorten down a lot with using dozens. But when it comes to chemicals, dozen isn't going to help us at all, because it's so many atoms and molecules in a sample of something that we can see. Dozen isn't even going to start to make this helpful at all. So what we need is a new unit that actually accounts for a lot of things. So a dozen counts for 12 things. We would like to have our own chemical version of a dozen that counts for a lot, and we call it the mole. So we say 1 mole, abbreviation MOL, and it's our version of a dozen. And it's a lot. It's 6.02 times 10 to the 23rd things. So times 10 to the 23rd means move the decimal 23 spots to the right. So this is a huge, huge number of things. But we need to have a gigantic number to basically take care of the fact that if you have a sample of chemical, you have so many atoms in it. So we use this idea as our dozen in chemistry, and it comes up a lot. We call it the mole.